Okay, hello. This is the video for the check-in, and I'm sorry that this isn't on screen capture, but I don't have a mic on my PC, so I'm doing this from my cell phone's video recording device. All right, so let's start the assignment and see what we get. Okay, this assignment will give you an opportunity to vocalize and demonstrate your understanding of the content. Please use such as to create a short screen capture of yourself talking through your thinking on the slides. Both of these softwares are free. The video capture should be at least 8 minutes long. The purpose is to communicate your current understanding. A link to the assignment. Have fun. I look forward to your responses. Okay, let's open this bad boy up. Welcome to sign in. Just continue with assignment. Oh my god. Desmos. Yay, Desmos, my favorite. This should be, Jesus. All right, consider the sample work and give it a score. Explain your choice. Okay. Evaluate the limit of okay, so if the limit of x minus a x to the a. Okay, function 0. Function or limit of x to the a. X to the a. All right, if I was going to do this, one half x squared is a0. If I was going to do this, I would not have done as x approaches a. I would have conjugated, which he did here, or they, shouldn't assume genders, x plus x plus limit x to the a would then be equal to x minus a on top. This would factor, and leaving this to not factor, let's not factor this. So that's x minus a over x plus a. Well, that factors that out nicely, so I could have just would have come out to 1 over x plus a. And then they go a step further and simplify and takes the, limit x to the a. So taking this to the limit a plus a equals 2a. So in the 1, 2, 3, 4, or 1, 2, 3, in the fourth step, he combines x plus a into 1x plus a, which I don't think that is the same. So my understanding of this is I would give him a 3 out of 4 for this first one, because he got everything up to the last step right. Or I should really stop. Oh, gender pronouns are hard. It's probably a girl too, based on the handwriting. I would give it a 3 out of 4 because he did all the steps right, except for his simplification. Because if this was written out right now, the only other thing is they forgot to do limit of x of a in a couple of steps. But honestly, that's something I do. So again, I would give it a 3 out of 4. So let's go on to the next one. Explain why the following equation cannot be guaranteed to have a solution. Okay. And it's got me writing some stuff I might have to. Okay. 3x, nope, 3 to the power of x plus the natural log of x over 50 cosine of x equals 0. The following equation cannot be guaranteed to have a solution. All right, so for this to equal 0, well, as far as I understand it, I don't think there's any way a natural log can be equal to 0. Let me just double check that on Desmos. Handy dandy Desmos. Natural log x graphed. Oh, blowing you down. Natural log of x could be 0. Can be 0, so it comes out to -5. That's nice. Okay, so 50 cosine of x. Interval. Well, let's just graph this whole bugger out. Power of x plus the natural log of x over 50 cosine of x. Equals 0. On the interval of 1 to 3. Well, I can see from the equation that if at 0, this equation comes out to 0. No. 0 point roughly 263. So let's say this comes out to x would, for this to be accurate, this would have to be x equals 0.263. And unfortunately, that falls outside of the that is outside of our interval of 1 to the 3. So what makes it do that? Well, I mean, if we multiplied both sides, we would get 3 to the power of x plus equals 0, and that would come out to 3x is equal to the negative natural log of x. Now, the natural log. So, if we did 1, so let's do 1 to the 3. So, it's just 3. And the natural log of 1 is zip. So, we get 3 equals 0, which goes out to 0. Now, if we, using using intermediate value theorem, if I remove this entirely and use interval value theorem, I would come out to 3, 1 plus the natural log of x, and then 50 cosine of 1. And just so we can speed this up, I will just write out the other half of that using plus natural log of 3 and 50 cosine 3, which can be rewritten as 3 natural log of 1 is 0, so that's just 3 on top. Cosine of 1. Let's just make that times 50 because I hate fractions. 50 cosine 1. There we go. Well, this comes out to roughly 27.01511. Actually, 12 if we're going to split hairs, which is definitely not below, is not zero. It's definitely not less than 0, so that's just malarkey right there. Going on the other side, 9 plus the natural log of 3 is roughly equal to 1.1, and the 50 cosine of 3 is interesting, negative 49 Okay, so this comes out to 10.1. 49.5. Well, that's definitely true. It does fall somewhere between 0 can definitely fall somewhere between 1 and 3, according to IVT. But that's assuming that's ignoring x equals 0. Or the f of x equals 0, rather. Basically, with f of x equals 0, it falls on a very specific place in IVT, which unfortunately you can't. This point doesn't exist between these two intervals once you, because this is saying f of x is 0, and this is saying the function. This is saying x between x and 1 and 3. If we worked back through this, we get 0.263, which is below, which is less than 1. So that is why this equation cannot be guaranteed to have a solution at 0. All right, given the graph of y equals f of x, sketch the graph of y equals x. Explain the key features of y equals f of x. Okay. Well, thankfully we have some handy-dandy graph paper here somewhere down. Just ignore the rest of the top of that. Okay, so we're given the graph of y equals f of f prime x. So let's just take a random spot on the left side here and have this be our graph. So from points -5, oh, I'm going to have to make it a little bigger. Actually, let's just have each one of the grids stands for an interval of 2. So -2, -4, 6, 8, 10, -10, etc. Okay, so at 0 we have a line, and it extends to halfway of 3 all the way up through -4. So that is our f prime of x starting there. And then we have the graph of 2. So if this is 2, so in this interval it would go to 2, which would mean go up by 1. There we go. Yeah. And if we do 1 again, it would go up by 2. 1, 2. And let's just keep on going all the way to 10. 1, 2, 1, 2, 1, 2, 1, 2. All right, that's okay. So, and this part of the graph, this goes to -5. So at -5 it equals 0. So right there. So it looks like it's the same relationship of, oh, this is 1, this is a 3. Okay, so Going up 3 again, 1, 2, 3, over 1. Going over 1 again, 1, 3. Going over 1 again, 1, 3. Going over 1 again, 1, 2, 3. Yep, here we go. All right. Okay, so going at this, I'm looking at this. This portion of the graph. Yep. Okay, I'm recording this. It's basically y equals -3. This portion of the graph, if we kept going down there, so this is f prime of x. Oh, nope, that's not how you do prime. F prime of x equals, so it's basically -3x. And then if we do some funky stuff here, 1. So it's -5 over there. So that equals -5. So if I did -5 equals -3x, we get y equals -3x plus 5. That's at 0. Yeah, 0. So at 0, what's plus b? So that be, so at x of, no, that's y of 0. At oh, it is difficult. Okay, so here x is, no, y is 0. And we know the slope is -3. Yeah, -3. So that's, and x is 5. So -0 equals -3 at -5 plus b. So this comes out to 15, so it has to be, so this comes out to 15. Then we subtract from, we add from both sides, so b equals 15. So this is f of x equals -3x plus 15. And just to double check that that's right, let's put it into a graph. Plus 15. Where's my graph? Oh, that is not right. So -15, -15. Okay. And I just typed in way too much. Okay, -15. Whoops. Yep. Okay, we're on the right track here. -15. There we go. There we go. All right, so this section is f prime of x equals -3x minus 15. Now, looking on this side is f prime of x equals, so it's going to be, the slope is definitely 2, so 2, and then we go at f of 1 plus b. Okay, so this is -3. 2, 1 plus b. So that's 2. So -5 equals b. And let's just double check that. 2x minus 5. And yep, 2x minus 5. So f prime of x equals 2x minus 5. Yep, okay. So now we know what our f primes are. So from here we can see that this, well, we can see that this is flat. So x, using our derivative rules, then this section, if prime equals -3, then regular old f of x at this interval must be -3x. So according to our derivative rules, is just simply x. So this has to be -3x from this interval. This interval would be, let's see here. So according to the subtraction rule, f the d of x f minus g equals f prime minus g. So working backwards from that, if we take this portion, -3x, well, we already know what the, so it would be this, but that's the, so -3x, so that'd be, to get that, it would have to be -1/2? No. 1/6? No. 1 over, well, for that to be x, the antiderivative has to be x squared. So x squared, and this has to be -3. So 3/2. 3/2. 3 times 3/2? No. 3. That's stupid, Andrew. This has to be 3, half of 3, half of 3, half of 3. Oh, -3. Yep, there we go. Okay. Then this portion would have to be -15 of x. All right, f of x in this section would have to equal 2. And then finally we come over here, where this is probably the most simplest one of all. If f prime or y prime equals 2x minus 5, then this is x squared minus 5x? Yeah, 5x. Minus 5x for those intervals. Now, we come over here and let's build up a new graph. It's going to be great. It's going to be super fantastic. Okay, let's build up a new graph. Okie dokie. So at the interval of -4, let's keep the 2, 1, has the formula of -3x. So let's just -3x. So at 0, get this at 0. So, and it goes all the way down. So for 1, it goes all the way down to -3. And then for 2, we go all the way up to 6. Okay, and from 1 onwards, we have x squared minus 5x. X to the power of x. Oh, no, that is not right. X squared to the power minus 5x minus 5x. Okay, we got a nice little parabola. Let's just put in some. All right, so at 1, we start at -4. 1 at -4. Then we go, so let's say 2 is -6. At 2, we're at -6. 3, we're also at -6. Cool. Oh, right over here. 4, -4. So 4, yeah, 4, -4. 6 at 6. Well, that went up fast. 6 at 6. 6, 1, 2, 3, 6. And because the graph keeps going from 10 to 10, let's see what happens at 7. 14. Okay, so we're off the graph at this point, but we can estimate. All right, so that's the interval. That's the interval from 1 to infinity. So let's take the interval of -infinity to -4. We said that the formula for that was -3 over 2 x squared minus 15x. And okay, so it's, well, at that portion of the graph we're actually already off the graph per se. So we're off the graph there. All right, okay, -1. Let's see what -3 is. -3 ain't even better. -4. -4 ain't better. -5. -6. -7. -8. -9. -10 is 0. So all the way over here, we got -10 is 0. Wait, 1, 2, 3, 4, 5. Okay, this is -10. And at 10, we get then we got like a point all the way up there at, let's see, -2, 2, so that goes all the way up there to negative 2 of 24. Yep, that's what I come out with for the formula of this. But if I remember right, a derivative formula has to be continuous. Okay, well, that's what I come out with this graph, and if I am wrong on my own head, be it. But that is the end of our session. I will be submitting this paperwork here in a second to the Gradescope, and hopefully it gets accepted. Okay.